Okay, this video is going to be on lesson 3, and lesson 3 is solving a system algebraically using substitution. So I don't like the class examples in the workbook for this, so what I do is you'll need my note package for this lesson, and this does correspond to page 627 in your workbook. So just if you needed to get there, this is on page 627, and then I think it might say lesson 2 on your note package, but this is actually going to be lesson 3. We're going to skip lesson 2 and we will come back to that. So the first page here just has the steps on how we do substitution, but I'll explain you these steps as we go through the questions. Okay, what is going to happen when we're solving a system using substitution is we're always going to get two systems. So this is system 1 and this is system 2. In system 1, they solved y for me, and they said that y is equal to x minus 2. So what I'm going to do is I'm going to box in what y is equal to, and then I'm going to look and I'm going to say, where can I substitute this in the second system? Y is equal to x minus 2. So here's where y is. I'm going to take that y out and I'm going to put in x minus 2. That's what substitution is. So I would have in my second system now, x is equal to 3 times y. And what did we say y was from the first system? Y was x minus 2. From here, you're going to get rid of your brackets. So you would have x is equal to 3x minus 6. And then you're going to see with substitution as we go through these examples is substitution is going to make it so that you only have one variable. And in this example, the variable is x. You want to always join your variables together because we're going to at the end solve for x. So from here, if I want to bring my x's together, I'm going to subtract 1x from each side. And then I would get 0 is equal to 2x minus 6. If I said solve for x, how would you do that? You would say, okay, I need to get rid of that negative 6 by adding 6 to both sides. Get rid of that negative 6 by adding 6 to both sides. Then divide both sides by 2, and you have what x is equal to. X is equal to 3. So now that we have one of our variables, we need to find our y coordinate, right? Because remember that this is two lines, and the solution is where these two lines intersect. So they're going to intersect at x is equal to 3, but what's the y value? So what I'm going to do now, systems, and I could plug x is equal to 3 in either one of these, and I will get value. However, system 1 is set up perfectly for me to plug it in because system 1 is y is equal to x minus 2. Y is equal to, I know that x is 3, so 3 minus 2. Y is equal to 1, and my solution would be x is 3 and y is 1. So that would be my solution. What we have to do is for all of your solutions, you always need to verify. So we've got two different systems. So I'll call this one system 1, and I'll call this one system 2. And when I verify, my first system is y is equal to x minus 2. My second system was x is equal to 3y. Okay, so what I'm verifying that x is 3 and y is 1. So 1 is equal to 3 minus 2. 1 is equal to 1. That verifies. On the second system, x, which is 3, is equal to 3 times 1. 3 is equal to 3. That verifies. Question. Second question. Y is equal to x plus 4. So I'm going to say, okay, that's what y is equal to. Where can I put that in the next system or into the other system? So if you look at the other system down here, it says y is equal to 3x. Up here, they told me what y is, right? So what I'm going to do is I'm going to take this y out, and I'm going to plug in x plus 4 for the y. So y comes out and I substitute in x plus 4. So now I'm just dealing with a second system. We got to combine our x's. And I would get 2x's. From here, we got to solve for x. Divide that by 2, divide that by 2. X is equal to 2. Now that I know that x is equal to 2, you have to say to yourself, okay, how do I figure out y? So to figure out y, you look at your two original systems. You could plug that x is 2 into either of these, and you'll get the exact same y answer. So if I plugged x is equal to 2 in the first system, watch what I would get. If I put a 2 here, 2 plus 4 gives me y is equal to 6. Let's say you decided to plug it into the second system. Y is equal to 3 times x. We know that x is 2. 3 times 2 gives me y is equal to 6. So it doesn't matter which system you plug your answer into, you're going to get the same y value in our system. So my answer is 2, 6. And then from there, you would need to verify. So plug your x and y into the first system, plug your x and y into the second system, and make sure that left-hand side equals right-hand side. Let's look at this class example. First system, they've nicely got y for me. Okay, so that's what y is equal to. So what I'm going to do is I'm going to box that in. Where could I substitute that box into the second system? So into the second system, here's where y is. And I'm going to simply take out that y, and I'm going to substitute in what y was solved, which is y is 2x plus 10. So now I'm working in the second system, and what I'm going to have is 2x plus. This y comes out, and this goes in, is equal to negative 2. We are now looking and we're solving for x's. So combine your like terms, and your like terms are these x's. 4x plus 10 is equal to negative 2. And let's solve for x. So get rid of that 10. 4x is equal to negative 12. Divide both sides by 4. X is equal to negative 3. So that's what our x is. So you got to take that answer and you got to bring it back to the top, and you have to say, where should I put that? Should I put that in system 1 or system 2? It does not matter. You're going to get the exact same answer. However, because I want to find out what y is, this would be the system that I would choose because it's already set up for y is equal to. So I'm going to plug that negative 3 into the first system, and I'm going to have y is equal to 2 times negative 3 plus 10. Y is equal to negative 6 plus 10. Y is equal to 4. So my solution for these two systems are x is negative 3 and y is 4, and I'm going to state that as an ordered pair, right? Because remember, these are all lines that I could graph, and the solution is where the two graphs intersect. Okay, if you were looking at this system here, ask yourself, one of them is already nicely solved for me, right? So which system would you box in? And I would look at this guy and I would say they've solved x for me. X is equal to this. So I'm going to box that in. And you always go from one system into the other system. Because I solved for x, where that would get substituted into, it's always the other system. So it would be 2 times what x is. So x is this guy here, 2y plus 1. And then I'd have to put this minus 3y, because I'm dealing with the second system now, is equal to 4. Okay, let's get rid of our brackets by distributing in that 2. 4y plus 2 minus 3y is equal to 4. We're going to be solving for y. So get all of your like terms together. 4y minus 3y is 1y plus 2 is equal to 4. Get rid of that 2. 1y is equal to 2. Divide out your 1, and we get y is equal to 2. So now that we have y, we got to figure out what x is. What's the x coordinate? So you go back up here, and you say, okay, I need x. Which one is set up to figure out what x is really easily? And hopefully you guys see that it's the first system here. If I plug 2 into the y and solve, I'm going to get what x is. So x is equal to 2. I know that y is 2. X is equal to 4 plus 1, which is 5. So where those two lines would intersect is at 5, comma 2. The majority of your substitution questions are going to be set up either like class example 3 or class example 4. Neither of these have solved an x or a y for you. So what you always want to do is you want to scan both systems, and what you ask yourself is, which system could I solve for one of the letters in only one move? And that is going to be this first system here. You could solve for x in one move, and that move is getting rid of this negative 3y. How you would get rid of that negative 3y is you would add 3y to both sides. And then what you've essentially done is you've just solved for x in the first system. And you said x is equal to 6 plus 3y. So now that I know what x is equal to, box that in and say, where can I substitute that in the other system? You always have to go from one system to the other. So the other system would be this system down here. Because I solved for x, this is what would come out, and that goes in. So it's going to be 2 times what x is, and x we got to be 6 plus 3y, and then it's going to the second system. So I got to include that 3y is equal to 3. Let's get rid of your brackets. 12 plus 6y plus 3y is equal to 3. Get your like terms together and solve for y. Okay, so the like terms together would be my y's. So 12 plus 9y is equal to 3. We need to get y by itself, so get rid of that 12. 9y is equal to negative 9. Isolate y by dividing by 9. Y is equal to negative 1. Now I got to go back. What does x equal? We have it set up for us for how to figure out x. X is going to be 3 plus 6 times y. So I'm going to use that equation to get what x is. So x is equal to 6 plus 3 times negative 1. X is equal to 6 minus 3. X is equal to 3. And my answer would be 3 comma negative 1. Again, for this verifying, like I'm skipping all this verifying to make the video a little bit quicker. So what we're verifying is if you're going to verify, you're going to have that's your x value and that's your y value. And you're always going to verify the original equation, right? So you would plug this x and this y into this first system, and you should get 6 as an answer. You'd then plug it into your second system, the x and the y, and you should get your solution. 3 comma negative 1 is verified. Okay, between these two systems, you say to yourself, what system can I solve for in one move? And it's this guy up here. I could figure out what x is in one move. I just have to get rid of that 4y. So to get rid of the 4y, I would subtract 4y, and now I know what x is. X is equal to 17 minus 4y. I'm going to box that in. And I'm going to say, is there an x in the second system that I could substitute that into? The x is right here. 17 minus 4y is going to get substituted in there. So 2 times 17 minus 4y minus y is equal to 7. Let's get rid of our brackets and solve for y. So 17 times 2 is 34, minus 8y minus, I'm going to put a 1 here, so 1y is equal to 7. Get your like terms together, which would be your y's. 34 minus 9y is equal to 7. From here, get rid of that 34, and you would have negative 9y is equal to negative 27. We've almost got y by itself. We got to get rid of that negative 9. So divide both sides by negative 9. Y is equal to 3. So now that I know what y is, I just have to figure out what the x coordinate is. I go back up, and right up here I've solved for x. X is going to be 17 minus 4 times y. We got y was 3. So x is equal to 17 minus, if y is 3, 4 times 3 is 12. 17 minus 12 would give us an x value of 5. So my x value is equal to 5. My ordered pair is 5, 3, and that would be your solution. If you were going to verify this, x is 5, y is 3. Where you need to verify is always into your original. You'd plug it into the first system and you'd get 17. You'd plug it into the second system and you'd get 7. It has to verify in both systems in order to be a solution, and you would be done. The homework is on page 629. So this is what I assigned from the homework. And then I'm going to upload a worksheet on substitution that has 10 questions. So I'll upload that worksheet and the solutions to that worksheet with this video as well.